All right, so we're going to transform this equation, which is in transformational form, into standard form and intercept form. And remember that with transformational form, it gives us some good information right off the bat, right? It gives us our vertex. Okay, so we're going to write that down. Vertex. And that vertex is going to be at -2, 11. All right. Now, it does give us the intercept if we remember the form, but we don't always remember that. And so a lot of times it's going to be easier for us to kind of move through a different set of solving, right? If you follow in the book, it will actually say, well, use your, was it -h plus or minus radical -k over a, and then plug in and go from there. I usually will say it's better to go to standard form and then into intercept form because we can use what we know about the quadratic. So let's first go into standard form. Remember, standard form is ax squared plus bx plus c. If we have transformation, we want to go to standard, just multiply. So this becomes,
How do you get -6 for the...
it follows the form x minus h.
Oh, you have to do all this. Okay.
You have to take the foot of x. Right? So we're going to multiply. So I'll do all of the steps, and you might be able to just kind of churn through this. But it's helpful for us to sometimes do it this way. And then positive 11, -20 is negative 9. And that's standard form. That's standard form. Now, you should notice that this negative stays with us. That negative needs to come down. Of course, the negative means it is concave down. All right. Now, standard form, the easy one. Intercept form is also easy, but requires a little bit more work from us. It requires a little more work.
That's why they're not big then.
Concave down because this is a negative. If that's a negative, then that means that it's concave down.
Is that the y equal...
No. Intercept form is y is equal to a quantity x minus s, b quantity x minus b. It takes the quadratic and splits it into two linear terms. Okay. Now, I've seen this done multiple ways. Some where you figure out the vertex and then you can backtrack into S and T. The only difficulty that we run into with that, quite honestly, is that there's a little bit of a guesswork that's involved. I like to do things that are going to work every time. And I like to be able to rely on the algebra. I know that I can do the algebra, I can churn through it, and at a certain point the algebra just starts to become second nature to us. So, what I want to do is to find the intercepts of this. And I know I can quickly and easily do that using the quadratic. Yes, sir.
Where does -5 parentheses, you get the a squared plus 2.
That one? Yeah. Yes, I did the sum squares. Yeah, the a squared plus 2ab plus b squared. Excellent. All right, so quadratic. -b plus or minus square root b squared. And again, I'm going to write all the steps out. You might be able to just plug it in.
Use the quadratic formula to go from standard to intercept.
I'm sorry, what?
Use the quadratic formula to go from standard to intercept.
Yes.
Always.
No. There are other ways to do it. This is just one method, and this is the method that I think is the easiest.
Could you come back to it?
If it's factorable, yes. If it's factorable.
Does it work every time?
If it's factorable, yes. But the problem that we run into is that a lot of times the things we're dealing with are not factorable. And I don't think this is factorable, right? 5 and 9, 5 and 3, yeah. So that's going to not get us anywhere. So I want to do quadratic. And the nice part about quadratic is that I know that it'll work every time. Right? I know that it's going to work every time. Even in higher level mathematics, if you're proving things, doing stuff like that, you'll see professors who just automatically default to the quadratic because they don't want to try and spend the time doing factoring because they know that the quadratic will work. So then 2 times a, which was -5. And again, quadratic, purely arithmetic. So 20 plus or minus, and I'm going to go ahead and do all that. So that is 400 minus 36 times 5, right?
Minus 180.
Would it be 45 times like 4? I got 2 like 190.
Yeah, so 45, positive 45 times -4 is the same as negative 36 times 5.
I got 240.
I just did it in a different order.
Oh, I thought you were saying that was like after all you like one.
Oh, no. Alright, so 220 over -10. Can I do anything with that just to kind of make my life a little easier? 220 is divisible by 4, so this would become 20 plus or minus 2 radical 55 over -10, which of course reduces down to, I'm going to put that negative out front, so negative, and then that'll be 10 plus or minus radical 55 over, or excuse me, 5. Alright, so I got that. Now I want to plug this into intercept form. I want to plug this into intercept form. And
I think you're rid of the 2.
I just canceled. I took a 2 out, so I took a 2 out of there, 2 out of there, and 2 out of there, 2 out of there, and 2 out of there. Now, remember my form for intercept is ax minus one of my intercepts, which in this case I have 2 of them, right? So I put the negative out front here on purpose. So negative 10 plus radical 55 over 5. And then x minus negative 10. And I put the plus here, so I'm going to do the minus radical 55 over 5. Now, again, I'm showing all the steps here. Each of them can.
Okay, why wasn't it -5?
I could have left it down there, but I wanted to put the -5 up here purely so I could have this become a plus.
Is there anything different about this from when you learned it in algebra?
No.
So,
No.
so the f of x, so that is just the integer. So it's just doing a plus, it's doing a second, so minus and 1 plus.
Not the integer, but the real number, yeah. Yeah, so this is, I didn't get a decimal. Right. And really the big difference between this and Algebra 2 is in Algebra 2 these always ended up being nice, neat, and little numbers because they would work backwards. Here, it could be messy, it could be neat. Okay. So, that's the beginning of intercept form. I want to simplify, and I need to solve for A. Right? I need to solve for A still. But again, I like using what I know about algebra. And these are all the same parabolas. So if I have a point that works for this one, I have a point that works for this one. Easiest point is the y-intercept. The y-intercept, again, occurs where x is 0. Right? So, x is 0. So, I'm going to plug in here. So I put in 0 here, that goes away. 0 here, that goes away, and I'm left with negative 9. So, I'm going to solve for A using this point. Now, could I have used any other point? Yes. I could have chosen 1, I could have chosen 2, I could have chosen whatever. But using x-intercept's nice because it allows all those things to cancel out. If I had chosen 1, then I'd have to plug in, okay, so I got -5 minus 20 minus 9, what does that play? I could have plugged in 57 and done the same thing. But 0 just gets us there faster. And that's a handy technique. It's one of those maneuvers. Okay. So, I'm going to go ahead and plug in, and I'm going to simplify at the same time. Because these negatives are going to become positives, right?
Okay.
So, -9 is equal to A. Then I've got 0 plus 10 plus radical 55 over 5. And 0 plus 10 minus radical 55 over 5. I'm just plugging in. Yes. All right, and at this point, I'm going to scoot this up just so I don't have to bend over. I'm just going to solve. So I've got -9 is equal to 10 plus radical 55 times 10 minus radical 55. And I multiply, so this is going to be over 25. And I just want to do that because it makes my life a little easier. I'm just going to start moving through -9 times 25. Yeah.
Why is this f of x? Why did we square it like multiply y?
This.
Like why did we set those up? Yeah, why did we set those?
Because intercept form says it's going to be f of x is equal to a quantity x minus one of my intercepts, quantity x minus the other intercept. It's based on the idea that a parabolic curve, and this one is negative, so it's going to be concave down, is going to look like this.
Oh, this is the parabola from the same sides.
Exactly, that's exactly right. And intercept form just puts this into linear terms. Remember, this is a linear term, that's a linear term.
So it's always going to be a parabola, so it always be the same size.
Yes, that's exactly right. It's going to be symmetric about some sort of line of symmetry. All right, and so I do this. This is, we've talked about the sum of squares, talked about the difference of squares. This is something called the sum and difference of squares, right? Which says that if I have the same term at the beginning, same term in the end, and I have a plus here and a minus, the resultant is the first term squared minus the second term squared. Which, of course, -225 is equal to 100 minus 55 times A. Whoops, got my A in here. Goodness gracious. So -225, is that 65? Is that right? 45, thank you. Arithmetic and I not getting along. And I divide by 45, A is equal to -1. So, my final answer for intercept form is going to be f of x is equal to -5 quantity, and then it's going to be x plus 10 plus radical 55 over 5 x minus, oh, excuse me, I did this backwards. This is the minus here as well. Minus 10 minus radical 55. Oh. You're giving me a weird look on it for a good reason. I fixed it the first time, fixed it back. Sorry.
Okay.
Good catch.
Oh, we're not done with that problem?
That is that problem. I've got another one where we're going to take something and that is in standard form and move it to transformational.
So what is that? Is that intercept form?
This is intercept form. This is the final answer in intercept form. Okay. Now, it's not a nice, pretty number. When we get further on into Chapter 4, we'll talk about the idea that something will have a rational number as a 0, and we'll see that sometimes that works and sometimes that doesn't.